So in the previous lesson, that was all like SOHCAHTOA stuff. Now we're going to talk about just angles. So angles come from like geometry type stuff. And once we get into trig, it's actually more helpful to start talking about radians. So I'm going to review what an angle is. So an angle is basically something that is formed by two rays. A ray is something that's like half a line basically. So you connect two of them, they form an angle. When we start talking about trig though, we start drawing them a certain way. We have two sides, and one of them is called the initial side. So I have a picture down below, and that picture, you can see a couple of things actually. It's got two different rays, and then it's got this little curve right here. So when we talk about the initial side, anytime we draw an angle, because that's what you're going to have to do in your assignment, the initial side is this bottom side. That's the initial side. So if you can imagine having two of those stacked on top of each other, and then grabbing one and swinging it around, that second one is called the terminal side. So in this picture, that would be the terminal side. So the initial side is where all angles start from, and then you swing the second arm around, and that's your terminal side. And I think they probably call it that because when you stop swinging it around, that's kind of where it stops. And another word for stop is kind of like when you terminate something. It's over, it's done. Now you'll also notice the little curve that's on the inside. Whenever you draw an angle, you have to include that because you can actually swing your angle around in different directions. So this part right here is important because it also helps us determine what type of angle we're working with. When we go in certain directions, that gives us certain types of angles. So down here at the bottom it says we're usually going to draw angles on the coordinate axis. So if you notice, now we've got the x and y axis. Anytime we're asked to draw an angle on the x and y axis, the initial side is the x-axis on the right side. That's where we always start from on graph paper. So I said earlier, we can swing the second arm in two different directions. If we go counterclockwise, So counterclockwise. I know not a lot of people use watches anymore because of smartphones and smartwatches, but I got the old school analog watch. Counterclockwise. So a regular clock goes this way. It goes to the right. Counterclockwise is to the left. When we swing our angle open to the left, the angle is going to be a positive angle. So this one right here, this is a positive angle. And then if you go in the opposite direction, which is like clockwise, then that angle is going to be negative. So the way I kind of think about it is the sign of the angle just tells us which direction to swing the arm. So this angle on this side right here, that would be negative. Now, until you get to trig, in geometry, all angles are just measured using degrees. And it's already understood from geometry that all circles are 360 degrees. That's one full revolution. So the way it's broken down is you just take each degree and break it up into a fraction. So it would take like 360 degrees to go the full circle. So 1 degree is basically 1/360th of a circle. When we get to trig, though, sometimes it's more useful to work with radians. Now we are going to be working with angles that sometimes exceed 360 degrees. So what you need to understand is one full revolution is 360 degrees. If we have to go beyond that, there is a way to draw the shape or the picture to show someone that we've gone beyond 360 degrees. And it has to do with the little curvy arrow, the one there where we show them which direction it's going to swing. If you have to go past 360, there's a way to do it, and I'll show you that when we get to some of the examples. So the way a radian works, and we talked about this when we did the AZ merit review stuff, a radian comes from the word radius. And anytime you're working with radians, radians involve pi. The reason why they involve pi is because you're taking the radius and trying to wrap it around the outside of the circle. We call that the circumference. So anytime you work with the circumference, the measure around the outside of the circle is 2 pi r. That's where the pi comes from. So if you can think about, like, I don't know, making a circle out of yarn and then cutting it and straightening it out, that's basically what a radian is. It's an angle that's formed in the center of the circle based on what chunk of the circle that you're dealing with. So the angle represents basically the measurement of the arc. So in this radian stuff, you saw that when we did the unit circle. There are 2 pi radians in one full revolution. So if you go around the entire circle once, that is now 2 pi radians. In your assignment, you're going to have to graph stuff that is beyond 2 pi radians. And like I said, anytime you go past one full circle, there's a way to draw it so that everyone understands that you've gone beyond 360 degrees, or the 2 pi radians. Now, when you guys draw the pictures, sometimes it's helpful to just do it in degrees. You can just do it in degrees, and then you can even use the unit circle to approximate where that's located. So it's going to be very useful to be able to switch back and forth between radians and degrees. And that's what's at the top of your next page. There's 2 formulas to convert back and forth. And the way I think about it is, remember earlier I said radians have a pi on it. There's one formula, and it's just written a different way for each conversion. So if your problem already has degrees on it, and you need it to go into radians, that means it needs the pi. So what you would do here is you would just multiply by pi over 180. So let's say you wanted to take 90 degrees and convert it into the radians. You have 90 degrees right here, 90 degrees. We know that's degrees because it has the degree symbol. If we want to convert it to radians, we need it to have the pi. So we're going to have to multiply it with the pi, but it has to have the 180 at the bottom. And if you do 90 over 180 in the calculator, that's 1 over 2. And guys, when there's a 1, we usually don't put it. So we just say it's like pi over 2 or pi halves. So pi halves is the same exact measurement as 90 degrees. So if you're going to go backwards, if it's in radians, it already has the pi. And if you need to convert it to degrees, the pi has to disappear. The only way you can get pi to disappear if it already has it is the pi has to go on the bottom. And I said earlier, it's kind of like the same formula, just flipped. So that just means the 180 goes on top. So a quick example of that is if I have 2 pi thirds, 2 pi thirds. It already has the pi. So I want to convert it to degrees. In order to change to degrees, the pi has to go away. Right now, the pi is on top. So to get the pi to go away, the pi would just have to go on the bottom. And then the 180 goes on top. Now you can do this entire thing in the calculator. Pi's on 2 times 180 is 360. 360 divided by 3 is 120 degrees. So when you convert back and forth, it's either going to put the pi on it or it's going to take the pi off of it. If it needs the pi goes on top. If the pi needs to go away, the pi goes on the bottom. Pretty easy to remember. Okay, so now I'm going to show you how to sketch both degrees and radians, both positives and negatives. So it says sketch the angle in standard position and then convert the following to radians. So they want us to do 2 things. They want us to draw it and then they want us to convert it to radians. So let me tell you some stuff about drawing the pictures. When you have to draw the pictures, if you have the unit circle on the formula sheet and it's on there, just use that. But for me, like I know some things, I know some basics, and I can sort of narrow down where it should be. For example, I know that straight up is a 90-degree angle, right? Everyone knows that one. Well, if that's 90, shouldn't halfway be 45? And if I want to do 30, shouldn't it be just a little bit lower than 45? So if I'm going to estimate this, this would be the initial side, and then I take the terminal side and I swing it up, but I want to go just a little bit less than halfways. Now to show people that I went in the positive direction, because honestly guys, there's 2 different angles that are showing here. There's positive 30 degrees, and there's also negative 330 degrees showing here. So to clarify to the people that are trying to read our picture, we're going to show them it's positive by drawing a little arrow that shows us which way we swung the arm around. Yeah, so this would be counterclockwise. So guys, the little arrow has to be there. If it's not there in your drawing, you get it wrong on the test. Okay, so check this out. When I do this stuff, I just try to break it down into things that I do know. I know some basic stuff. I know that 90 degrees is straight up, and I know that this is another 90, so that's basically 180. So if it's 210, wouldn't that just make it 30 degrees past 180? So that's how I do it. I try to just break it down into things that I know. I know some basic stuff. I know 90, 180, 270. I know all the, basically like all the multiples of 90. I know where they're at. So then I base it off of that. Now the only thing about this one though is it's negative. So when I do this, I have to swing my arm around the opposite way. Normally we would take the arm and swing it up. Because it's negative, we're going to have to swing it down. So if I swing the arm down to the other side, that's 180, and 210 should be 30 past that. So it's kind of like maybe right here. To show people it's negative, I draw the arrow that goes like this. Oh, I didn't convert. I almost forgot. Second part of this says convert it to radians. So if it has degrees, where does the pi need to go, on top or bottom? On top. Yeah, it goes on top. Because when we convert to radians, it needs the pi. So if I convert this to radians, 30 over 180 reduces to 1/6. And you could just write this as pi 6. And if you guys take a look, if you look at the unit circle, any fraction that has a pi on it, the pi is always on top. That's how they write it. Why is it pi? I'm not swapping out 1 for pi. This is 1. Yeah, okay. Well, no, I don't think that's what you thought. It's 30. Whoa, hold on. It's 30 pi over 180. The 30 and the 180 are reducing to 1/6, and because the pi's already there, we don't have to put the 1. Okay, next part. It says convert the following to degrees and then sketch the angle in standard position. Now again, if it's already on the unit circle, just use the unit circle. The unit circle does have pi force on it. You don't have to really convert if you don't want to. But for me, my mind works in degrees. I know 90 degrees, I know 180 degrees, I know 270 degrees, and I know like kind of how to estimate based off of those. But if you're not able to do that, like with the pi force and you don't have that circle memorized, you can just convert it. Right now it's in radians because it has pi, so we would just have to put the pi on the bottom to make it go away and multiply it by 180. If you do that in the calculator will automatically cross out the pi's, and that's going to leave you with 45 degrees. So like I said earlier, I know all the 90s. I know all the multiples of 90. So 90 is straight up. 45 should be halfways. And since it's positive, I show everyone it opened up that way. So same thing with 5 pi 6. If you're not good at thinking in terms of like the fractions, turn it into degrees. So we can multiply this again by the pi on the bottom and the 180 on top. And I believe I'm doing this right. I think that's 150 negative. So I have my initial side. Right here is where it starts. And because it's negative, I have to swing it down. So again, guys, 150. I know 90, I know 180. So it should be kind of close to 180. It's 30 degrees off of 180. So if I was to come all the way around to the other side, that's a perfectly straight line is 180. So I have to go 30 before it. So something like this. And then we show people that it went this way. Now, there isn't an example on here of something that goes beyond the 360. Remember how we talked about that? There's ways to do it when it's more than one full circle. I just want to show you one of those real quick, and then you're going to practice on your own. Someone give me a number bigger than 360. 380. That's the first one I heard. So watch this. If I want to graph 380 degrees for someone, this is how I break it down. 380 is the same as 360 plus 20 more, right? So if I want to show someone 380 degrees, that means that I take my terminal side and I swing it around and I do one full revolution, but then I go an extra 20 degrees. So 30 is kind of low, so 20 should be a little lower. Now, that looks like a 20-degree angle, though. So to show someone I did a full revolution, I start here and I go all the way around and I go past the initial side, and now that's 380 degrees. So anytime this little curl passes where you started, that tells the people that you went past 360. And I'm showing you this because you're going to have to do that on the assignment. If you have it in terms of pi, all you got to do is, basically all I did was 380 subtract 360. That's all I did to figure that out. And if it's in pi, just subtract 2 pi, because 2 pi is a full circle. And if it's more than that, like let's say it's 9 pi, 9 pi would be 2 pi, 2 pi, 2 pi, 2, there's 4. Yeah, so it'd be 4 times around, and then another halfway around. So that's how you can break it down. Just break it down into full revolutions, and then you can do your little swirl and show people that. And that's it. That's what you have to do on the assignment. So the assignment we're on is 12.2, and I want you to do both sides. The back side has logs on it. It's going to be a good idea that we start, because we're almost done. Remember all the bell works? Our bell work from our packet from first semester, it only goes to 30. So what I'm probably going to start doing is I'm going to start pulling log problems back, since test 8 was the worst test we did all semester. And there's still only like 7 people that retested that one. So I'm going to start pulling those up, because we need to practice. We need to get better for the final. Yeah. Both sides.